Hi everyone, welcome to today's video. In today's video, we'll be looking at the factory design pattern and we'll be looking at its benefits. We'll also have like a small demo where we showcase the powers of the factory design pattern. I will use an example, try like a almost real life example that we can relate with, and hopefully we get the point, and also how we can integrate with this in our code basis is very important. Now, the factory design pattern majorly is a creational design pattern. It's used majorly when you want to create objects. Yes, you have different objects, but you want to dynamic most of the time you want to dynamically uh, call or invoke those uh, classes, or I mean objects. So let's go into a code and look at how it looks like. So here we have this code, and if I just run that now, we'll see that it come up. So what we will see is an application. It's just a small console application that is for a boxing competition. And it's just a validation system where each boxer is validated to see if or not is eligible to partake in the boxing competition. So the criteria for boxing as of today, or let me say yesterday, was the weight, the height, and the strength or power. And these are the 3 points for which we'll be checking or validating the user to see if he's eligible or not. So for the height, he must be taller than 150 centimeter. For the weight, he must be more than 60 kg. And for the power, his power must be less than 300. So just for a minute, just assume there's a parameter called power or strength. Yes, so maybe strength must be less than 300 so that maybe it doesn't blow off people around him. So uh here we can put in the first, so height, and I say probably the height of this person is 90. If I go with this, it tells me that the user is not eligible, and it tells me the reason is because the user's height is 90 and is not up to the allowed height, which is 150. Or similarly, I could want to try again, and I say, okay, so height this time around, let's give it 170, and let's say the weight. So the weight, let's say it's 80, and let's say I'm good with that. It tells me that the user is eligible here because, as we can see, the weight is more than 60 and the height is far more than 150 centimeter. So it means this user is eligible to partake in this boxing competition. So majorly that is what it is. You see here, it allows you to be able to validate by whatever. So if you want to validate by the height, it allows you. If you want to validate by weight, it allows you. And if you want to validate by power also. So let me just do that quickly. So power, and let's say the power is 700. Now this will not be eligible because the maximum allowed is 300. So this is just how it looks like. So let's look at the code and see what is going behind the scene. So we have to I what I just did, I wrote out a sketch out for it so that we just talk about it and look at what we have here. So without the factory pattern, so here we have a class, the without factory pattern validation. We can just go in there and see what we have there. So within the validate method, one approach we can use, the ideal approach we will normally want to use conventionally, is just to use if else. So for example, if the validation, if it's height, we want to compare with the allowed height. We can see here we have the allowed height is 50, the allowed weight is 60, and the allowed power is 300. So we check if the data point, that is the data, it's less than the allowed height. So we are okay with that. If it's not, then we know that we have to add this error message. If we do the same thing for the validations for weight and for power, if any of these validations is picked. So, and at the end of the day, we'll just put them together to concatenate them. Basically, that's just basically what this is. So we see how it is done, and this is what is giving us the result we have now. Now, let's say tomorrow they come up with a new validation, and let's say for the boxer now, We're now talking of the uh, boxer speed, for example. So we want to also validate by the boxer speed. What we will have to do, we need to come here and alter this logic here and validations, and then we could put, can say for speed, this is how we'll go about this. And we can say the speed. So we need a data point for speed. So let's just say the allowed speed. Let's say it's 30 meter per second, just for whatever the implication of that is. So, and here we are checking that we want to show that the data point is always should, we expect that the data point should be at least 30. That means we are checking if it should be greater than, so that means if the data point is less than this, we want to try an error. Allowed speed. So here we could just allow me to copy this here and here. So you see that here is, so the data point is, or rather I think just copy this thing here about the thing, and then we can use allowed speed. Allowed speed. Now you see we had to make modification to the very class where we had done this, and with this we could introduce a new bug into the system now, and for whatever reason now, and because when we build our applications, we want to do it such that we do not alter what we have within our code base. So with this now, it comes with, depending on how complex, imagine if what we the logic within each of these was very complex algorithms that were going on there now, and because I am trying to do it within this place, I could alter the flow or the logic or the pattern with which it goes. So it becomes very something we need to be very careful about. And this, so for example, in my if I wrote a unit test for this prior to this, I will need to go to the unit test and alter that unit test also to accommodate for when we have a speed, for example, or as it is. Now, this is what we will do to achieve that. So if I was to run this now, we will have speed. Now, but what the factory pattern does, factory pattern shines in a thing like this. So, for example, and for example, it means if a new user come, he needs to understand, okay, this logic is like this, and this is how the logic goes for him to go ahead to do what he wants to do here. So let's look at how the factory pattern looks like. So let's go back to program.cs. In program.cs, uh, in program.cs, so I will have to, let me just comment this out just for ease. So you see here, I have this validation factory. Now, if we go to the validation factory class, you will see here what we are just doing is simply, so normally this will be your dependency container. I just want to simulate that. Now, I will show us the three implementations. So what the factory pattern has is it isolates, it decouples it. So when we go back to this without the factory pattern, you see everything is coupled together, the height, the width, the power, and now the speed, everything is just coupled together in one place. Now we want to simplify it. Factory pattern, it can help isolate every component and make it decouples our application basically. So you see, we have the height, we have that for the height, we have for the weight, the logic for the weight, for the power, sorry, you see, we have it separate, and we have the logic for the weight separate. All of this is isolated. So if I want to do a make a modification to the weight, for example, I know that all I need to do is to come to the validate weight implementation and fix it there, for example. That will be it. Unlike with for the scenario where we did not have a factory validation, a factory pattern, we had to go to the class there and look at it and say, okay, this is the weight, okay, I'm trying to modify. But with this, it is clear that okay, this is for validating the weight. Now, if you look at this I validation, it's just an interface, and it has two property. It has one property, the validation reason, and has a method, the validate, that returns a boolean, which is whether it validates true or false, and then if there's an error message, we have the error message. That's strictly what we have here, and that is makes it much cleaner. So if we look at it, basically the logic inside of each of them is as we saw in the other one, but where it shines, this is now the factory. So like the name implies, it's like a factory where when you want to manufacture something, you go to the factory. So it's like a manufacturing point. And so just for example, for sake of this tutorial, just take this as the dependency container, the dependence the di container, so that we have our container here. Just for simplicity, let's just take that we have this I read only list of I validations. And what we are doing here basically in our constructor, in our validation constructor, is that we are just forming a dictionary. This is just to make it easier to fetch, because the dictionary gives us an O of one search time, so it gets an instantaneous search. So we just do this at the when the class is created, so that we have these validations available, which is just a dictionary, and it has a string and an I validation as the value. Now, if we look at it, the key, which is a string, is the validation reason. So, for example, if you go to the height, the validation reason is height. If you go to power, the validation reason is power, and for weight, it's going to be weight. So, what this does is it will group them. For example, it for weight, for height, and for power, for example. That is just basically what this we have. And then what this just does, it goes through my list of validations and just checks for each of those validations. For example, if the keyword I pass is height, it checks for the height. It says get me the key, I mean the validation I validation implementation that has this key of height. And then based on that, I can now go into it. So if I go to the implementation, for example, you see it has three implementations. So when it gets the one for height, it knows to go to the height, and it just does the computation for the height and comes back with a response. Basically that. And you see what we just do is just at the end of the day, we just gather our data and then we put it together. Basically. So this is much cleaner. So if I will just put a breakpoint here just so that we can see how this, I'll put a breakpoint at the constructor too. So when we run this now, we'll see how it simplifies things for us. So I will just put, so let's just say the height is 70, and let's just leave that. So we see here our validation. You see we have three validations. I've said we should just take this as our di container, and so what it just does is it splits them. So if I were to put a breakpoint here so that it's clear there, you see that the validation, we have three items there, and the key for this is the height, and it's the implementation we have here is the validate height. Why for the weight keyword we have the validate weight, and for the power it has the validate power. So with this now, when it goes to do the validations, it knows that my validations, what I passed in was the height. So it knows to come here and check for a key that is the height. So if I press continue, we have validation key here is height. And if it checks our validation available variable, which is the dictionary, the height, it gets the validate height implementation, goes there, runs the implementation, and goes back. And if we press continue, we see it tells us user is not eligible for the following reasons, just as with the implementation with that did not have make use of the factory pattern. Now, one other reason why this is very good approach is that when you want to, for example, as I said, you want to have a new validation for speed, all I don't need to come and understand the complexity of what is in the height or the logic in power or the logic in width. I just go to create a new implementation, for example, and I could just create a class, and that will be the validate speed, for example. And with that, I could just have this. Now just permit me to just copy for the height. It's basically the same. So we have something like this, and with this, and then just make the speed, and then the speed allowed, let's say 50 physically, and then we're okay. So I could just the allowed speed, and that's it. And with this now, we know that if I need to touch or make a modification to my speed validation, this is where I do it. And sorry, we shouldn't forget that this must implement the I validation interface. All we just need to do is in our factory, we just need to in our container just needs to uh know about this speed. So if I was using an API project, for example, I will have done this within my program.cs. And you see, this will not actually be uh, touched. I mean, this will not be something we come to the class to do at the class level, at the factory level. So basically, there will be no change at all to our factory. There is no change to any of the other implementations. And all we just needed to do was to add our new implementation. And if we go ahead to run this, we will see that it worked fine without any hassle, without any making modifications to this. And for example, when I'm working on my unit test, I just know that I need to just do unit test for this class and it will not have impact on any other class, which makes it very clean. So speed, and I give it 20. I know it has to be more than 20, so it tells me that the user's height. Oh, okay, so I did not change that from height, so the just speed and allowed speed, and that's just it. So if we run it again, we'll see that it works, and this is where factory pattern shines. I use this quite. I like to use this when I want to make dynamic decisions in how I create, or I want to make a choice within the left and the right. I tend to use the factory pattern in this approach. I've used it for validations like this, and it's a very good design pattern to have in your toolkit for different scenarios. I hope this was helpful, and I hope we enjoyed it. Please let's like, subscribe, and let's share this video. If you have any comments, you can drop in the comment section and I'll be sure to interact with you there. Thank you.